29 was a pretty challenging one to take a look at out of that section. I think if you can do 29, you can do any of these. So the idea is they're going to give you a trig value, and then they're going to also tell you the quadrant that it's in. And you're going to use that to find it's actually all 5 other trig values since you already have one. The key here is draw a picture and think about the definition. Okay, the secant is the reciprocal of the cosine function. So the secant, instead of being adjacent over hypotenuse, would be hypotenuse over adjacent. Or if you want to use the coordinate definition, cosine is x over r. This would be r over x. Either one of those definitions will work, okay? But you want to get a picture that kind of matches up with this, okay? So I'm going to draw an angle. It needs to end in quadrant 4, okay? So anyway, I'm going to start out here. We've got my initial side of my angle. I'm going to rotate around, and it's going to end somewhere in quadrant 4, okay? So make a triangle, and this is your reference angle right there, okay? Technically, theta is this angle, but the reference angle is the angle we're going to be using to set up our triangle, okay? So trig values are always fractions, okay? Radical 10 is not a fraction, so make it a fraction. Okay, and let's match up with these definitions here. So it's radical 10 over 1. That's telling me I need to have a hypotenuse of radical 10, and I need to have an adjacent side to the angle of 1. The adjacent side would be right here. I need to use the Pythagorean theorem to find that third side of that triangle. Okay, so I know that 1 squared plus, maybe we can call that y squared is equal to radical 10 squared. 1 plus y squared is going to be equal to 10, y squared is going to be equal to 9, y is 3, okay? But be careful. This goes over in a positive direction, this goes down. That really should read as a -3. So remember, x and y could be positive or negative. The hypotenuse is always going to be positive, okay? And so now we can fill in our other trig values here, really just using the diagram we have. So again, you can use your traditional definitions, or you can use the new definitions here. Doesn't matter which ones you want to use. So sine of our angle would be the opposite side over the hypotenuse. That's negative 3 over radical 10. Okay, now you should rationalize the denominator. It'll be -3 radical 10 over 10. Okay, the cosecant is the reciprocal, okay? Just flip it, and don't flip this because this has a radical in the denominator already. When you flip it, you'll have the denominator in the numerator, which is where you want it. So it'd be negative radical 10 over 3, okay? We already have the secant, right? The secant's just this. The cosine is going to be the reciprocal of that. Cosine is, of course, going to be adjacent over hypotenuse, 1 over radical 10, which is going to become radical 10 over 10 if you rationalize the denominator. Okay, if you keep going with this, tangent is the opposite side over the adjacent side. That's -3 over 1, which of course is really just equal to -3. And of course the cotangent is just going to be the reciprocal of that. That'd be -1 over 3. It'd be -1/3. Okay, again, you don't have to do it this way. You could use the coordinate definitions. You could say I'm going over 1, down -3. I'm passing through the point 1, -3. And sine is x over r. Sorry, sine is y over r. Y over r. That's x, that's y, that's r. And you can see y over r would give me that. Cosecant is r over y. Cosine is x over r. Tangent is y over x. Cotangent is x over y. So whether or not you want to use the old SOHCAHTOA definitions or the new spiffy coordinate definitions, doesn't matter. You'll get the same answers either way.